If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everybody, welcome back to Anantha Lakshmi Academy. I am Anantha Lakshmi today here to teach you the very important concept of logarithms today. Even before covering the logarithms of chapter 1 real numbers, we have already covered the concepts of number system, Euclid's division algorithm, LCM and HCF, and rational numbers and their decimal expansion and irrational numbers. I have uploaded all the videos earlier even before to this. If you are directly coming to watch this video, please make sure to watch those videos as well so that you get a better understanding. If you are not able to figure out where exactly they are, I'll be attaching the playlist in the end card. Please go through it, or in the description also I'll be attaching the links. Alright, so let's get started with very important concept, logarithms. Alright, logarithms. Here you get to listen to this word for the first time here in 10th class. Alright, so once you have a base here, you will be solving more and more logarithmic problems in your later classes as well. So make sure, do not skip this topic and make sure to watch this video till the end to get a better understanding of what exactly this is and how to solve these problems. Alright, so let's get to the concept of logarithms. Why, where do we use logarithms and all? So first let's get to the exponents. If you have already, you must be already familiar with the exponents part, right? Like 2 power 0, anything power 0 is 1. If I write 2 square is equal to 4. 2 cube, it becomes 8. Right, and this goes on, right? 2 power 4 is equal to 16 and all. But when I say 2 power x is equal to 16, how do we solve this? We get to solve this like 2 power x is equal to 2 power 4, since bases are equal, exponents are equal, and x value is 4. But when I try writing 2 power x is equal to 5, how do you guys solve this? When 2 power x is equal to 4, if I give you 2 power x is equal to 4, you get x is equal to 2. But when 2 power x is equal to something which is not a direct multiplication of 2, how are we going to solve this? This is where the logarithms comes into picture. Alright, how do you find the value of x? Here 2 power x is equal to, when I write 5, if I apply the logarithms, how does it become? In order to know the value of x, I am applying logarithm. That becomes x is equal to, what is the base here? 2, right? Logarithm short notation is log 5 to the base 2. The base remains the same. Here base is 2 and here base is 2. So understand this. This is read as, this is read as log 5 to the base 2. Here the base was x, exponent is, base was 2, exponent is x. The same base we are taking here but writing a log. Alright, do not think too much about it. There are some formulas which we have to remember, right? Assume it to be a formula like this. I'll go to the generalized statement later, but to have a better understanding, I have given you an example first. Where do you use logarithms exactly? When you equate some power of any number to something which is not a direct multiple, then this is how we solve it. So 2 power x, what power of 2 is 5? That can be given by log 5 to the base 2. What power of x 2 is 5? That can be given as this. So the base remains the same. The log comes first and then the number and this. Alright. So let me put a generalized statement. If a power x is equal to n, then x becomes, how can I write it? As per the example, log n to the base a. where a greater than 0 and a not equal to 1 and n is also greater than 0. Okay, if a power x is equal to n, it implies that x is equal to log n to the base a, where a is always greater than 0 and this is not equal to 1. A is not equal to 1. What happens? If I substitute 1 in place of 2, 1 power x is 1 power anything is 1. So that is never equal to 1. A is not equal to 1 and this is always greater than 0 and the number n is also greater than 0. Okay, once you get to know this, we have few important formulas or which are known as logarithmic laws. Not LOSS, it is LAWS, alright, logarithmic laws, using which we will be able to solve the problems, alright. So we have understood what are logarithms, where does they come into picture to figure out what power of any number is equal to the other number. We use logarithms. And how do we use it? When you write 2 power x is equal to 5, x is equal to log n to the base a. That is how we write it. That is a generalized statement which we have already known. First thing is, when if a power x is equal to n, what does x become? Log n to the base a, which we have already learnt. Now, second thing is the product rule. Product rule is nothing but log xy to the base a is equal to log x to the base a plus log y to the base a. If there is a z associated with it instead of xy, if it is xyz, then it goes like log x to the base a plus log y to the base a plus log z to the base a. Alright, so remember this product rule, log xy to the base a is equal to log x to the base a plus log y to the base a. This and all, the simplification part of it is really very well given in the examples. So please go through it. Now that why am I not explaining the explanation part is, that and all you can understand from the example problems, but these formulas you have to remember, only then you will be able to solve the exercise problems. Okay, so I am giving out the laws for you first. Next, which is the third one, which is quotient rule. What is it? The quotient rule. When does the quotient occur? When we do some division part, right? So log x by y to the base a is equal to log x to the base a minus log y to the base a. This is a quotient rule. Earlier we had a plus sign. When it is plus sign, this is going to be the product. When you have a minus sign, this is going to be the division. Alright, for this simplification also, this is given in the example. Please go through it. That is the reason I always stress on going through the examples. How to achieve at these things is given in the examples. You make sure before jumping onto the exercise, you please go through the examples. Alright, next one is the power rule. The powerful rule. It's not the powerful rule or the one which gives you power, but it is something which is related to the one which is available in the power. So what happens? Log x square to the base a or log x power n to the base a is equal to n log x to the base a. This is a formula. Now that this power is on the number x, what happens when the power is on the base? Let's see that. Log x to the base a power n is equal to 1 by n log x to the base a. Alright. Now, what if there is a power to the base and the number? Log x power n m to the base a power n becomes is equal to m by n log x to the base a. So these are the very important logarithm laws which you have to remember. So first thing is a power x is equal to n implies x is equal to log n to the base a. Product rule is log x y to the base a is equal to log x to the base a plus log y to the base a. Quotient rule is log x by y to the base a is equal to log x to the base a minus log y to the base a. Power rule is quotient rule is when you do division. Product rule is when you do the multiplication. Power rule is when you have power either to this number or to the base. When you have power to the number, then it becomes n log. When you have it to the base, it becomes 1 by n multiplied with log x to the base a. When you have in both the ends, the numerator will be to the number, the power of the number, and the denominator will be the power of the what? Power of the base. Alright? Yeah. Here, apart from the logarithmic laws, there are few things which needs to be considered and remembered, of course. The first thing is what happens when the logarithm is in the power. What happens? A power log n to the base a. This base and this base, when these two bases are equal, it is nothing but equal to n. Alright? This is the 4 laws we have written, right? This is the 5th one. And 6th one, in order to put a generalized statement, this is not exactly another law, but this is something which can be derived from the very first law. When a power x is equal to n, x is equal to log n to the base a. That is what we have written, right? So let us try figuring out, like, what is 2 power 0? If I suppose 2 power 0 is 1, right? Using this formula, can I write it as 0 is equal to log 1 to the base 2? Can I write it like x is equal to log n to the base a? 2 power 0 is 1. 0 is nothing but log 1 to the base 2, right? So now 3 power 0, let me try it as 1. What does that imply? 0 is equal to log 1 to the base 3. Now 4 power 0 is equal to 1. What does that imply? 0 is equal to log 1 to the base 4. So what is this indicating? Log 1 to any base, 2, 3, 4, if I go on, log 1 to any base is nothing but 0. So that comes a generalized statement of log 1 is equal to 0. Okay. This is not a separate rule, but this is something which can be drawn from the very first law which we have learnt. Now, can I write it like 2 power 1? 2 power 1 is equal to 2. So what happens now? 1 is equal to log 2 to the base 2. Alright, 3 power 1 is equal to 3, which implies 1 is equal to log 3 to the base 3. 4 power 1 is equal to 4, which implies 1 is equal to log 4 to the base 4. When n and a, I mean the number to the same base, is always equal to 1. So this can be written as log n to the base n is always 1. Alright. These are the same things which we have derived from the already learnt first law, which this is like, when you remember, this might help us in solving problems. Alright. I hope you guys might have already gone through the examples. So let's get started with the exercise in the next video. That you have known what are the logarithmic laws, I would strongly recommend you guys to go through the examples wherein you find the simplifications of how to arrive at these laws as well. Please go through them, and once that is done, we can jump on to the exercise part. Alright, so if you feel that the content is worth enough, please do subscribe to Anantha Lakshmi Academy. Also, please share it with your classmates and any 10th class students in your circle. So wait and watch for the next video on logarithmic problems. Alright, thank you for watching.